All right, in this video, we are going to introduce programming and the programming language Python. Really excited about it because I love programming, and Python is such a beautiful and simple language. I think you're really going to enjoy it a lot. I'm going to share my screen so you can see what I'm doing, and I'm going to begin on this website called Replit. And I mentioned Replit in the very first intro to Python slides, but I wanted to just kind of show you what it was and kind of talk about what programming is a little bit, because I know we have some students in the class that have never done any programming before at all. So I'm going to start at the very beginning. You can go, it's replit.com, or, if you just open up a new browser and just search for Replit, R-E-P-L-I-T, it's going to be the very first thing that pops up for you. So we're going to come here into Replit, and when I click on Start Coding, it's going to ask you to sign in. I always just sign in with my Google account, but you could all make a different account, as well if you wanted to. So whenever you sign in, it'll look like this. And up here in the top left corner, there is a Create button. You can kind of see where my mouse is. It says Create in blue. And if I click on that, it says, okay, here we are going to create the workspace for writing a new program. So you can imagine, like, if we were writing an essay and we created a new Word document, that would kind of be like what we're doing here. This is just where our program is going to go, the environment that we are going to write it in. And Replit is a really nice environment to work in for several different reasons. It's online, it's free to use. You do want an account, but that kind of helps you save your work, but it doesn't cost anything to make one. And number three, because you're running everything online, you didn't have to set anything up on your computer to run it. Traditionally, if you were going to write programs and run them locally on your own machine, you would have to set up the programming environment to do that. You would have to download things and install it, and you might have to change like environment path variables and all sorts of overhead that you would need to do to be able to get programs to run on your computer. You don't have to do any of that if you use an online editor such as Replit. And there are some other ones, but Replit's a really good one. It's very popular, and it's the one that I will be using for the examples I do in class. If you want to program in a different environment, that is completely okay and your choice, but I recommend Replit because it's easy. So when I say create REPL, it says it's asking me what language I want to write a program in, because there are lots of different languages that you can write code in, and we'll talk about that in the slides in just a second too. In our example, we are going to, for this whole class, we are going to be using Python. So Python is right here, and it will automatically give you a name of just like a random, text generator. It's just sort of gibberish. I will just call this Intro to Python. And be aware that the programs that you create are all public and other people can see them and access them if they click on your profile, unless you pay for your account to make it private. So just a heads up on that. Okay. And there's some things here where they'll kind of show you around a little bit, but I'm going to go over that myself. So I'm just going to click out of it for now. Right here, this white space is where we're going to write our code. This is kind of like a command prompt. This is our console here where we're going to execute the program, and we'll see the result of what we do. And then over here in our file manager, we can see all of the different files that we have in our workspace right now, because you might have multiple different files. You might have your program that you wrote. You might have some input data that your program might need to access to be able to do some things based on that input information. And you might have some output information. You can write programs that will write out to other files, and then you might, save the results of whatever you ask your program to calculate for you, or whatever answer you were trying to generate. So that's sort of the setup of what's going on here. You might notice that this program is called main.py. So that's a file extension that you might not have ever seen before. We're kind of used to like, .png is a picture, or, .doc is a Word document. .py stands for Python. The pi is for Python. And so this says that this document, this file, is Python code. And so that tells the computer that if we were to run this document, it understands that the lines that it reads in there are instructions that we're giving. Writing a program is giving the computer a set of instructions, and it knows what it is supposed to do with those commands based on, oh, it's Python code. I will read in these commands and understand them as Python. It's a Python program. Okay. So I'm going to be using this to show you a couple of examples. I'm going to go through the slides here. There are 10 slides in the intro to Python. I think, okay, here, the file type is Python intro. The file name, I'm sorry, is Python intro, and these are PowerPoint slides you should have in D2L. Okay, so Python is a programming language. We're going to just briefly go through it here. It was created in the late 1980s. So it's been around, long time, right? That's 40 years since the 80s. That's wild. So what does it mean by general purpose? I mentioned before that there are lots of programming languages, and some of them have a very specific purpose. They were written to do one thing, and they do that one thing very well. But that's kind of all that you use it for. So some examples of that would be some early languages like Fortran. Fortran was used for formulas. It was really good at doing calculations. And so you would use it, if you needed to do really specific calculations. If you were designing a bridge, you would want access to Fortran, right? But it would not do you any good if you were trying to develop a video game, for example. So Python is general purpose. It can be used for lots of different applications. High-level language, a high-level programming language means it's kind of more like English. The words that it can read and understand are going to be closer to what we as humans would understand. That is in contrast to a low-level language, which would be written in a way that would be easier for the computer to understand. I mentioned last week when we were learning the binary number-based system that the computer stores information as ones and zeros. That's how the computer understands our data, and that's how it transmits the commands, whether it should send a signal or turn it off. So programs that are written closer to machine language, which is going to be all ones and zeros, are going to be low-level languages. And then programs that are written more in, just conversational, like regular, like you and I would just speak to each other, would be a high-level language. Python was meant to be really simple. That was kind of the whole idea behind it, that it would be very understandable. These are different types of programming. We maybe won't get too deep into that, but there are different paradigms of programming, and Python's very versatile because it can cover multiple ones. Dynamic type, we might not get too deep into either, but I will mention that in a second when I show you an example. We'll kind of talk a little bit more about how the way that information is stored within your program. Python can look at the data that you are trying to save, and it can determine what is the best data type to store that information in. It can decide that for you, and it can store it that way sort of behind the scenes on its own. So dynamic is like during runtime, during execution, it can figure that out and make a really, it's going to make its own decision on the way your information is stored. That's going to be in contrast to some other languages where every time you want to store some piece of information, you have to tell the computer specifically, hey, I'm going to give you a word. I'm going to give you a sentence. I want you to store this data as a sentence. And so then you have to tell it what data type that is. Or you have to say, hey, I want you to be able to do math with this. I want you to save this as a math data type. And actually, that is a very common issue with reading in information in Python. And that's going to be a big concept that I hit in our next video. It's actually something that could give you some fits in your first program if you're not careful about it. So it is really important to understand that Python is going to automatically determine the data type of how it stores information for your program, and it doesn't always make the right decision. So sometimes we need to overwrite that and say, hey, I need this data to be stored as numbers so that I can do math with it. I'm going to specifically tell you, make this information a number data type. Okay. Automatic memory management. If you have any experience with C or C++ and you have felt the pain of pointers, you might be jumping up and down with joy right now that Python's going to handle all of that for you kind of behind it. And then here is really why Python is as popular as it is. Python is a very popular language. Number one, because it's simple. And number two, because of the library. It has a huge library that allows you to bring in commands that gives it so much functionality. So here's what I mean by that. A library in computer science, when we talk about a library, we are saying that these are a bunch of commands that you may or may not need. Like not every program is going to use them. So the example I used earlier, you know, if you're writing a program to design a bridge, as opposed to if you're writing a program to make a video game, you're going to need very different sets of commands available to you. And what computer scientists realized a long time ago is if you had every single command available, if you tried to make them all accessible to every program at all times, your programs are going to be huge for no reason. There's no reason. You don't need to include hundreds of thousands of commands that this program doesn't need. So you're going to waste a lot of space and your programs are going to run very slowly because they're having to include a bunch of information that you don't need. It's very wasteful. And so they had this brilliant idea. They said, okay, well, we will just have a small amount of very basic commands that we think most programs are going to need. And that'll just sort of be built in and available to everybody. So if you write a Python program, you're going to be able to use print because a lot of programs are going to want to have the ability to print. That's just sort of basic. However, if you want to do some specific, you know, you're going to make graphs and maybe not everybody is going to want to make graphs. You can you can import the graph library. And now you're going to have access to all of those commands. It gives you the ability to have more application, more functionality for your programs. And it allows you to bring in additional commands, additional things that you can do in your program that are very specific to what your end goal is, what you're trying to write it. Python is interpreted. So that means that it's going to, every time you give it an instruction, every time you have like a line of code, it is going to immediately convert that line of code into machine code that the computer can understand, and it's going to run that line, okay? As opposed to some other languages. So like if you've taken CS1 and we wrote programs in C++, C++ is compiled. We talked a lot about the compiler. and you had to take your whole entire program, compile the whole entire thing, and then it would run all of the instructions at the end all at once. And interpreted language, it just runs one line at a time. So this video is actually really good and it's pretty short. It's only a couple of minutes long. I would suggest following that link and watching that video for some more on the differences between being interpreted and compiled. One other thing to know about it being an interpreted language means that you can type an instruction directly in the command prompt and run it and execute it. So what do I mean by that? Here is where I can write a program and save it and store it. So like I could write a program here and I could save it, and this would be in a file, and I could send that to other people. I could save it for later. I could open it up and make changes on another day. This is how you guys will write your assignments, because then you can take this file and you can submit it and turn it into D2L, right? So we could write just like some really basic commands here. Could say hello world, and we could run it and it says hello world. I get my output over here in the console. It's beautiful. However, because this is Python and it's interpreted, I could choose to write a program over here in, the actual shell. And I'm going to get the exact same result because I don't have to compile it. I don't have to have a whole different file. It's not creating a class file. It's not creating an object file. It's not doing anything else like that. It'll just translate it and run it right there. So that's an interesting thing that is a difference in Python compared to maybe some of the other languages you might have experience with. Okay. History of it. So this kind of, we talked about it being invented in the late 1980s, and then it's had some updates over the years. There are different versions of Python. We are going to be working in Python 3.0, which came out, I guess about 15 years ago. It's a simple language, like we said before, less cluttered grammar. That's a huge one. For some programming languages, and there are rules in Python as well, but for some programming languages, there's sort of a lot of overhead in all of the different little syntax that has to be exactly right for your program to run. A big one is that in several other languages, you have to have like a semicolon at the end of every line, or you have to use like curly braces to show all of your different, like what's part of a loop or what's part of, a function or something like that. And Python really doesn't have some of those same rules. You don't have to put a semicolon at the end of each statement in Python. We don't use curly braces. You do have to indent, so it does still have a rule, but it's less cluttered. It's not as much typing. You don't have as many little symbols that are part of it. It really was written to try and be simple. And then what they mean here by extensible is kind of what I already talked about. There are so many packages that you can bring into Python. It's a good language to use for so many different applications that really contributed to its popularity and why it's used so much today. So it's a fantastic language to use for, oh my gosh, so many different things. What I personally use Python for a lot is this one down here. It's used a lot for machine learning and artificial intelligence. And that's something that I have tried working in a lot because it's one of my research focus. And we've used Python in a lot of the classes that I have worked in. Also, natural language processing is this kind of text processing down here. You do that in Python. There are a lot of libraries built in for it that make it really simple to use Python for that. Okay. So here's our first program. If you've ever done any programming before, you might know that the sort of standard, just kind of like stereotypical first program you write is hello world. And it's really interesting. I think there's a website you can go to and it has like the hello world program in a lot of different languages. You can kind of compare the complexity of some of the different languages. Python is beautiful. You want to print something on the screen, you say print, and that's it. I have parentheses around everything that I want to be included in my print statement. You can notice there's no extra syntax, no semicolon at the end. Why do we have quotation marks here? The quotation marks are going to show us the difference between I want you to print exactly, literally what is inside quotation marks. So that's called a string literal. A string is just words, sentences, characters, a letter. It can be literally anything. And then literal as in exactly what's in the quotes, right? So this is going to print out exactly what was inside these quotes. You don't always use quotation marks because sometimes we want to print out something that was stored inside of a variable. And so if I wanted, so like if I said, you know, what is your name? And you said, Jim Bob, I want to say, hello, Jim Bob. Well, how do I have that information? How do I have, you know, whatever the user input as their answer? I need to store that somewhere. So I would not, like I couldn't say, hello, Jim Bob in quotation marks because I wouldn't know what the name is. I don't know what they're going to type in. So you want quotation marks around print this out exactly. And then you do not want quotation marks whenever you're using a variable name, where a variable is some data that's been stored in the computer. We'll talk more about that later. In fact, I'll show you a little example of it right now. So here we have hello world in quotation marks. It printed out exactly hello world. We could also have some data. I could say x equals 42, yada, 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 meaning of life. If I said print x, notice that here there are no quotation marks. I don't want it to literally print out the letter x. I want it to say x is some piece of data, and I want you to go find that piece of data and give me the information that's stored inside of it. So if I run this program, it prints out, well, if I run this program, oh no, my computer's being slow. Okay, sorry about that. My computer got a little hot running everything. So if we run this, it does print out the hello world because that's in quotes. So we get hello world exactly. And then when I say print X without quotation marks, it doesn't print X out. It goes and finds what value is stored inside of X. It prints out that information. One other thing that you might notice if you have programmed in another language before, and there is a difference between printing and staying on the same line and like an extra command you have to give it to go down to a new line. You don't have that in Python. It's automatically, you know, saying print hello world, go to a new line, print 42, go to a new line, right? There's hello world, new line, 42. You can see my carriage return right here is on a new line as well. So there is no extra command to go to a new line in Python. If you wanted everything to be on the same line, you would have needed to have just put it all within the parentheses, saying print out this entire statement altogether. Okay. From current slide. So here we kind of just saw that example of a second script. If I wanted to store data somewhere here, like if x equals 6 and I printed out x, I would get the 6. You can do mathematical operations directly inside your program. So here the asterisk means multiplication. So it's saying get the value that's in X, 6, multiply it by 7. 6 times 7 is 42. It's going to do everything over here on the right-hand side first, and then it's going to store the final end result over here in this location on the left-hand side. So the order matters here. And in this example, the equal sign does not mean equals. And that's something that when people first come into programming, it's a little bit hard to get used to because all the time you were in math, this meant that these two things were equal, right? And that's not what it means in computer science. When you are programming, the equal sign is the assignment operator. It says, I want you to go do whatever information, whatever data, whatever end result is over here on the right. And then I want you to store that end result in this location over here on the left. So if I switched the order of this command, if I said X times 7 equals Y, that would not make any sense. And it would give me an error. The program would not be able to run it, right? So because I'm saying, do this work, store it, this is my destination, and the order does matter. You can't swap those things. So here, 6 is being stored inside of X, but if we swapped the order, if we said 6 equals X, that would not make any sense, and we would get an error for that as well. You might be wondering, well, what do these little, greater than symbols mean? What are these little carets? This is an indicator that this is being ran in the command prompt. We mentioned that you can do that we could have written our program just right over here. So if I said like, what is X? Oh, well, it doesn't have an X, just kidding. If I said like, what is, 6 times 7, it can do that and it'll tell me that it's 42. So these little arrows are an indicator that we're working over here inside the shell, over here inside the console. However, you would not really want to do that. You wouldn't want to put everything directly in the console if you were going to write a complex program, because you would want the ability to store that information and then you can make changes to it later. You can, save it. You can send it to somebody else. You can submit it for an assignment, right? This is talking about the difference between typing your commands over here, but then when they're done, they're lost. The results of what's over here are not saved anywhere, as opposed to if I write my instructions over here in a file, right? This .py, this is a Python file. I can save these instructions. I can come back to it later. Here where these little 3 white dots are over here by my file name, I could choose to download this program, and that way you could submit it into D2L. You could, if you were at work, you could send this to somebody that you were working with, or actually in Python, you can program collaboratively. But my point is that you can save files for later. You can come back to them. You can edit them, and they're stored somewhere, so they're saved. As opposed to anything I type over here in the console, if I leave this, but if I were to, close out of Replit altogether, if I were to just completely close out of, that window and come back to the work that I was doing later, I can open this up and have stored the commands that I had written in my file, but it won't necessarily have stored the things that I had written over there in that shell script. Okay. And then here, one more example, and then I think we're going to wrap this video up. So if I had like a big program, if I had something complex and complicated, I would obviously want to write that over in the white part of my section in the actual file, where I could save it for later. So in this example, and this is a more complex example, and we'll be going through a lot of these commands later on, but you could see that if I had a lot of stuff going on, that is something I would want to be able to save. So this would want to be written in the file itself. And here is an example. I kind of mentioned it earlier, but here is an example of Python using indentation. This command has been tabbed over to show you that this command is part of this loop that came up before it. Anything that would have been indented over would have been like part of this loop. And down here, you can see all of these are tabbed over because they're part of the loop. And then these are even tabbed over again because they're part of this if statement. And we'll go through that in another video. Okay. So lots of environments available. I talked about that at the beginning of the video. I'm going to be using Replit like I showed you, but you can use a different editor if you are more comfortable with it. I recommend Replit because it's free, because you can just run it online. You don't have to set up stuff on your personal computer. It makes it easy, you know, if you're going to do like your project partner or something that you can work together and collaborate. It's really neat. There are some links here available. If I go through these videos and you feel very confused, if you don't feel very confident, there are lots of tutorials online that could help you, learn program commands a little bit more in depth, learn Python commands a little bit more in depth. And also, as always, you're welcome to come to the Zoom calls and we can work out some examples and write some more programs together that way. So that's it for just introducing it. And then in the next video, I'll go through some more of those Python commands that I mentioned, some of those like built-in commands. And we'll talk about how you can do some simple math. We'll talk about how you can store data in variables and some of the rules around what you can and cannot name things. And we're even going to talk about getting some input information from a user. So have a good day.